Sometimes in surface texture analysis, we want to capture a locally bad region. For example, this surface may have a zone that's rough in the middle, and we want to understand the worst roughness in a zone. That's what the maximum height per section parameter does for us. What we're going to do is we're going to choose a section of the surface and calculate the total height in that section, and then move this section along one data point at a time. Now in this case, where this section currently sits, it's relatively smooth. There's a low peak to valley roughness in this region, but as the section moves over, perhaps to this position, that section contains a higher peak to valley roughness, in this case, if it's a roughness profile. So the height of the worst roughness in a section is the RZX parameter with a given L value as the section width. So we're going to sweep a section that's L millimeters wide through the data and report the highest roughness we encounter at any position along the way. Now this parameter again is like the T parameter. It's the highest peak to valley in the window. So if that's the case, that means the PT parameter and the RT parameter can be influenced by dirt. They can be questionable because we don't know if we're measuring the actual surface or perhaps some dirt that landed on the surface. However, this is a very useful parameter if we're looking at something like waviness and we want to know if the surface is going to seal or not. For example, in the world of waviness, this surface has a dip in it. The waviness dips in this zone, and if we sweep a window of some width through this surface and we want to make sure that the surface doesn't change too much along its path, we would see that at some point there's a very large change, or a large WZX parameter that occurs in this middle zone. So WZX could be a great way of catching a ripple in waviness. And again, we're going to choose the width of the window that we slide through the data one point at a time. Now the defaults for the window width for roughness, the default is going to be our roughness cutoff, the long filter cutoff. We call it lambda C. For example, it would be 0.8 millimeters is a common length for the roughness analysis. For waviness, if we don't include a long filter, we're going to use the evaluation length divided by 5. Similarly, for the primary profile, we will use the evaluation length, the full length of analysis divided by 5 for our L values. So the length that we slide through the data is user selectable. And if we don't select something, we're going to use our filter cutoff for roughness, or 1/5 of the length in typical cases for waviness and primary analysis. So the X positioning of the Z height is a useful parameter. We're going to slide a window along X and capture the worst Z, or the worst height in the window. And again, it might be a useful parameter for things like waviness, but be careful for things like roughness or primary.